QCX Robolab is FLSmith's solution for using flexible robot technology to prepare ore and process samples for analysis. When the samples arrive at the laboratory, the barcode is scanned and thereby the sample is logged into the QCX system. The first step of preparation is drying, and the sample is paired with and placed in a drying tray. The sample trays are mounted in a tray rack, and in this laboratory the samples are inserted manually into a drying oven. After drying, the operator inserts the racks with the dry samples into the automatic tray in feed, and from there the samples are handled automatically. The tray in feed is designed to handle 4 racks, each with 48 samples, without human intervention. Here the samples are again weighed and original moisture content is registered. Then the sample is crushed in one of the 3 large jaw crushers. The crusher output weight is used by the QCX software to determine possible sample blockings. One of 2 rotary sample splitters divide the sample into one portion for further processing in the pulverizing cell and one archive portion that goes to the bagger and the rest to reject. In order to avoid cross-contamination, both crushers and splitters are cleaned after each sample. The archive sample is bagged in a forming, filling and sealing machine. Cross-contamination is avoided as the sample feeding tunnel is flushed after each sample. The archive sample is barcode labeled for easy identification before leaving the cell. From the splitter in the coarse preparation cell, a sample portion is discharged directly into a grinding bowl in the pulverizing cell. Here it is pulverized in one of the 6 large capacity mills. After pulverizing, the sample portion is split into a portion for further processing and a reject portion. The QCX programming structure allows for one of the mills to be out for service, while the system makes optimum use of the remaining equipment. In a thorough process, the grinding bowl and puck are individually cleaned with high-pressure glass bead blasting in order to avoid sample-to-sample contamination. The sample portion coming from the pulverizing cell is split into a large cup in the sample dosing cell. The dosing cell consists of 1 sample dosing unit and 1 fire assay doser. First, the sample goes to the sample dosing unit, where it is dosed into several sub-samples. 1 for further processing in the fire assay doser. 1 or more as duplicate or triplicate sample. 1 which leaves the sample dosing cell in a capped vial with barcode. This subsample is used for additional analyses and archive. The dosing unit is highly flexible. It can produce up to 4 individually weighed outputs of either cups or vials or a combination of both. In the fire assay doser, sample, aliquots and fluxes are dosed in an enclosed environment in order to get optimal, constant and stable sample mixes ready in the ceramic crucibles for fire assay. The lead dust from the flux is extracted in the machine. By automating this step in the sample preparation process, human exposure to lead dust is minimized, and what is a large health issue in most assay labs is addressed. Once the samples leave the fire assay doser, it is assayed and finally analyzed with ICP. The buffer rack in the dosing cell functions as a storage rack for QA and QC samples. Each sample type has its own specific sample preparation recipe. Such a recipe can be changed by the operator to accommodate for future needs. During the sample login, the QCX software links the desired sample recipe to a sample. The specific recipe determines the sample's way through the automated laboratory, as well as the specific preparation parameters such as grinding time, amount of backup sample, etc. The event-based operation of the QCX software ensures a greater degree of flexibility and a high capacity. If one piece of equipment is out for service, the software will automatically choose an alternative route for the samples. The software will allocate a sample to the next available machine and thereby increase total sample throughput. Because all sample handling and machine control is done by the QCX software, it is easy to change or add new sample recipes, new pieces of equipment, etc. The overall QCX QA/QC software controls which samples shall be duplicated or triplicated based on the sample recipe and overall QA/QC scheme.